and then we'll talk about some best design practices to use in Mongo, and then we'll see how to install MongoDB, and then we'll compare semantics between SQL World and Mongo, and then we'll talk about the operational factors, and then finally we'll come to the drivers that connect to the Mongo database from various clients. And there is support for various languages: PHP, Java, C#, and so on. And then we'll do a Mongo C# driver overview, and then we'll top it off with an example of C# connecting to MongoDB using MongoDB C# driver. We'll do a crud operation: create, read, update, and delete. And then finally we'll wrap up with some index creations and queries using uMongo, which is a SQL Server Management Studio equivalent for Mongo. With that being said, let's start off by defining document and document databases. So document is a set of name value pairs that include both data and metadata. So in this case, what I mean by data is that it's all the related information is for a specific entity will be stored as a document. Let's say for student, in typical school world, we have been taught about denormalized structures where addresses, phone numbers, and any other additions will be in its own separate tables. But in document databases, the goal is to keep as much information relevant to a specific user in the same record, which is a document. Okay, so then we'll see what document databases do. So they essentially store and retrieve data that are not predefined, which don't have predefined formats. So the same student record that we are going to store may have a first name, last name, date of birth, and some other student record may have first name, last name, and GPA, the fees that he has paid, and so forth. So there is no standard structure for the documents, although there is some commonality that we would like to keep, but the whole goal is to store different documents that don't have a standard structure but still be able to retrieve them and query them would be the goal. Okay, so they are also called as semi-structured because they have some kind of structure but not a full structure. Okay, so let's talk about what is MongoDB. It's a document-based database again. So what do I mean by NoSQL? I hear the term NoSQL pretty frequently. So whenever we talk about SQL, we talk about denormalized structures, like again the same example: student, addresses, phone numbers, whatever. And then again, if we are trying to store all that information together instead of the denormalized SQL structures or table structures, that's when we call it as a NoSQL. So it's like more like a document-based structure. So when you're reading a document, you have all the information relevant. So that's what I mean by NoSQL. And again, in MongoDB, documents stored are in BSON format, which is a binary strongly typed JSON. As I said, it has drivers for many programming languages, and it supports embedded documents. So we'll talk about the embedded documents in a bit here, but essentially it is a denormalized data model where you don't want to really duplicate a lot of information that is going to frequently change. So let me get my laser pointer here. On the left hand side, I have the SQL annotations like table, row, column, and the foreign key, primary key relationships and all that stuff. And the right hand side, I have Mongo relevant terms. So a collection in Mongo refers to same thing as table. So if there is a student's table, there will be a student's collection. And if there is a row, we treat it as a document in Mongo. So a record for a student is same as a document for a student. So similarly, there is a column maps to field. So a first name or a last name column similarly maps to a corresponding first name field or a last name field. When we are talking about columns, we are talking about fields in Mongo. And the relationships that SQL achieves can be treated as embedded documents. So all the relevant contact information addresses, phone numbers, or whatever that is, are stored as embedded documents within the same document. Okay, so that's the terminology that we need to remember. Again, collection is same as tables, document is same as rows, field is same as columns, and embedded documents represent something of more of type relationships. Okay, let's move on and see how do we install and set up MongoDB. So once we go to this URL, it's called downloads. Well, you can even Google search and say MongoDB downloads, and it'll take you to this page. And there is support for Windows, Linux, Mac, whatever you name it. But in this example, we will use the Windows operating system. So I have downloaded it already, and here is my folder that I have. Extracted all the folder files into this MongoDB, and it gives you a nice structure. Server 3.0. We are using the 3.0 version of MongoDB in this session, and I have created a folder called data to store all my data files, obviously. So you'll have to create that folder. It will be initially empty, and by default the journal is enabled to me, and all the journal data will be stored here. We'll talk about journal a little bit more deep. So essentially after that, the next thing we are probably going to do is navigate to this path, the bin folder. If you look at my structure here, it all comes default. The only folder that you will end up creating is the data folder. Okay, and then you have your bin folder right here. So you navigate to that folder, and then we set up. Once you say mongodb.exe and set your DB path, all your data files will be stored at this location. You can set it up as a Windows service. There are instructions in that folder, in that web page for MongoDB downloads. But for this specific case, I'm just going to keep moving by just saying using the command line prompt. Okay, and that's it. You're all set up and running for MongoDB. So let's talk about the operational factors that we need to consider. Okay, first thing I would like to talk about is atomicity. So a write operation can only change one document at a time. That means you can have bulk operations. I mean, you can insert multiple documents in one shot using bulk. But again, if you're trying to access multiple objects, like the multiple collections, then you would not be able to achieve that in a single transaction. So it doesn't support multi-object transaction. So that is very key decision that you need to make when choosing MongoDB. It doesn't support multi-object transactions. So that's one thing. And the next thing I would like to talk about is sharding and replication. But before that, let's talk about the number of collections. When I say keep as much relevant data together, it doesn't always mean you should store the entire world in one collection. It's a design, it's an art. So you'll keep learning. Let's say if it's a school information, right? Why would you like to store the entire school data in a student record? You don't do that. So you create a separate collection for school, and school will have its own set of information. At the same time, you just store the information about the scores and the classrooms that the student attends, which may change, but again, that would be a student relevant information that you would like to store at student record. Again, it's a design art. Like I said, don't hesitate to create a number of collections as long as they don't intertwingle. You don't have to read a lot of joins, because joins are pretty costly in document database worlds. So you'll have to be a little more careful when designing your collections, that not to separate too much of data or not to cram too much data. Okay, so typically a large number of collections means it has resulted in a good performance in some of my prototypes that I have built. The next thing that I would like to talk about is sharding. So sharding is a database architecture that partitions data and stores the data among two or more database instances. In Mongo itself, there are multiple ways that you can shard. One is by key ranges and the other is by hash tables. I mean the hash of the data. We'll talk about the different types in a bit here when we go to actual sharding and replication in better depth. And then we'll talk about the indexes. What are indexes? In SQL world, we have indexes. It's the same story here. Again, with indexes, each index takes about 8 KB of data space, and it helps in some data lifecycle management techniques as well. Let's say there is a capped collection. You can say my collection is capped, so it will have a certain size, and once the achieved size is achieved, the new documents will be overwriting the oldest documents in your collection. It's called like, it acts like a circular buffer. Let's say you allocate a certain amount of space and the last thing goes out first. It's a LIFO. Okay, it's a stack. Yeah. So the next thing that we would like to talk about is the sharding and replication itself. Let's go and talk about it in a little bit more of a depth. And also there is like time to live and all that, which we'll be talking about a little bit later. So another thing that I want to talk about that is when journal is enabled, your writes are persisted to the disk within 100 milliseconds typically. At that point, even if you unplug from the wall, the data will still be durable. That means you can still retrieve it even after a hard restart or something like that. So always enable journal. It may create a little bit of overhead, but I always recommend it because it saves a lot of heartache, especially when dealing with your production scenarios. So let's go ahead and talk a little bit more about sharding and replication. As we talked about the concept of sharding, again, it's an architecture that distributes data split out across multiple across multiple servers. So it has three important components: the shards that store the data. It could be 2 or more or how many ever. And then it has this application query routers. So what it does is application query routers talk to the client, and they decide, okay, when I need to get data from the database, which shard do I need to talk and get the data from. Again, that shard information itself is consistent in the config servers, which store it contain a mapping that says, okay, this cluster's data set belongs to this shard, and so it will appropriately query out the data for you. Okay, and the process of replication itself. So the client application talks to the driver, and there is always a primary that is selected. Again, it's a process of synchronizing data across multiple servers. So all it does is a replica set creates it's considered as it has a group of MongoDB instances that host the same data set. So the primary takes the writes, and all those operations are applied on the secondary data sets. So it helps us in two ways. One is you would like to write all your reporting from your read-only database, which is your secondary, and also it acts as like a disaster recovery process where you always have another copy of your database running, and you can quickly switch out which one to be your primary depending on the failures. Okay, and one thing that I always also recommend is, if there are a lot of reads, then why would you not have another read it from the secondary database? Okay, so if the primary goes out, you can still query the secondary, but again at that point you'll have to change your secondary to something else because one of these will be picked up as your primary. Okay, no big deal, right? Simple sharding and replication. These two things are highly recommended in MongoDB production environments. Okay, I thought this slide is pretty funny to describe more structured versus unstructured. So the structured SQL has like a defined way on how it's all designed, like a suit and a tie, and unstructured, it has its own advantages. Like you could have your jeans, typical jean shorts or whatever. But again, I have great respect for both those gentlemen there. So let's keep moving. So let's talk about how to do your data models. Okay, so in your typical SQL databases, we denormalize structure as much as possible. So user can have a contact document which is split out and all that. But in an embedded document model, which is how our MongoDB has to be designed, so all you do is you embed another document into your main object. Let's say you're storing movie information, which is Horrible Bosses 2. The genre is funny, and you have your contact information for that movie is right here, which is an embedded subdocument. And again, the pay rate for the director or whoever that is pretty high. Oh man, I should be going there and working. All right, let's keep moving. So you get the point of embedded data model, right? So all your relevant information are stored as embedded subdocuments. That's what embedded data model means. In the next slide, we'll talk about how to not duplicate information, which is one to many. So if you look at the left hand side of this document, I have two students, Tom and Christy, and the name of the teacher is Sridhar, and his skills are math, English, and physics. And you could typically you don't want to duplicate the teacher information too much, because it may change tomorrow. My skills may change to English, or I'm not interested in maths and physics anymore. English and poetry, maybe, whatever that is. Okay, so with that being said, Tom and Christy, so they could have a reference to an ID of teacher, which is teacher underscore ID. Again, the ID is unique across this entire database, so I could just say ID is simple example teacher. I'm just showing it for the simplicity. It will be an ID which is more like a grid kind of look and feel, if I have to say. And then this is how you get it. You store the teacher information is in one place, and you don't want to duplicate it too much, because another good example would be a book and an author. The author could be having many books, and let's assume it will be one author per book. It could be many authors, but again, I want to illustrate my point that it is possible to have your identifier stored here. It may be the case that you don't need the teacher information always, so feel free to just save the student ID, teacher ID, just in case it has to be ever retrieved. Okay, you can always get by ID, so store that ID. So let's talk about indexes here. There are various types of indexes. So what do indexes do? They support efficient execution of queries, and without indexes, MongoDB has to perform a scan of the entire collection. So by default, there is an underscore ID. Each collection, each record or document has an underscore ID, which will store an object ID, which is unique. And by default, there is an index created on the underscore ID field. So in addition to those, if you want more, let me show you some index syntaxes here. So if you want to create an index on a student, which is a single field index, and this is how you do it. DB is like the way to access MongoDB, and DB dot, let's say in my student collection, which is my student table, I would like to create an index on the name in the ascending or descending order. +1 is for ascending and -1 is for descending. But really, MongoDB can traverse in either direction, so it doesn't really matter. As long as you have an index, you're good. The next thing is a compound index. Okay, let me pull that back up. The next thing is a compound index. Let me see where that is. Oops. What compound index does is you can have index on multiple fields. Let's say on a student, you could have an index on name and GPA. If your queries require both, then create an index on both of those. And the order of the index like which field do you mention first and which field do you mention second is really important, because that dictates your performance of your indexes. Okay, there may be situations where you would like to have indexes on your arrays. Let's say a list of phone numbers for a student, that's an array, right? It could have multiple phone numbers. So in that case, if you want create index, then if you can do this. But MongoDB is smart enough. You don't have to specify it as a multi-key index or a compound index. Depending on what you're trying to do, it'll automatically create that specific index. So essentially, if you're trying to create an index on an array, let's say example would be a list of phone numbers, then that's called a multi-key index. What else? So we have text indexes, which enables the MongoDB supports text search, and there are also geospatial, hashed, and whatever other indexes that may be, which could be of some interest to some audience, but I will leave it out for your own exploration. The other thing, very important concept that I would like to mention is a TTL index, which is a time to live. So it determines how long a document gets, how long the documents get stored in your database. After a certain time expiration, the document will automatically be booted out or removed from the documents collection, from the collection. So the imagine this scenario, right? Exchange rate. It doesn't change every second. So it changes only a day. So you could have an exchange rate web service that you'd be calling, and you could store that in your Mongo database, and all your web servers on the farm can query your Mongo database and supply the value of the exchange rate. So it's one way to see if you want to introduce Mongo database, then that could be one of the typical scenarios where you don't have information that is changing every day, but again you could still use it as a cache. Why would I not want to use cache? Because I have to keep the state, and I have to expire it at a certain point of time, and it has to be across multiple servers. It all scales out much better if it's in a Mongo database. I can do various operations and whatnot. Okay, again I could have a record of all the things that have been served and all that. So it's one way to introduce MongoDB to your environments, where the information doesn't change every second, but you already have a SQL database, and this is one of the places if you want to introduce. The next thing I would like to talk about is our drivers that connect to Mongo databases. So we'll talk about the C# official driver. Okay, so what happens is when we want to request a document from a MongoDB, it returns a BSON document, and the driver transforms that into a POCO or JSON, whichever we want, the client expects. And again, when the client submits the POCO or JSON, whichever is its way of dealing things, and then we will deal with the transformation. The driver deals with the transformation of the JSON or POCO to the BSON document, which is a Mongo server. Okay, so let's move on and do a drum roll for the live CRUD sample. But before we do the CRUD sample, I would like to show you how the driver transforms a BSON document into a string or an array or a JSON, and then how it transforms a POCO object to BSON or JSON. Okay, so let's take a look at that real quick. So what I have is essentially let's talk about this test case. So what I'm trying to do is I have a company, and Charlie Sheen being my favorite actor, I'm going to have a name my company as Charlie Sheen Acting Services. Years in business is 100. And is it public company? Yes, I would like to make it public. I'd like to get some public money here, and as in my investment. Again, I have contact information, addresses. So all I'm trying to demonstrate is this is a POCO object. Let's go take a look at the object itself. So I try to demonstrate all types of commonly used data types, which is integer, string, boolean. One thing I would like to specify and point out is there is no support for decimal. So whenever there is a decimal in your POCO object, you would like to typecast it to a double using the using this attribute. Let me increase the font of this so that you can take a better look at it. And again, I have support for arrays, which is a list, but again it will be transformed to an array of things. And I have a embedded document, which is contact information, which is having email and phone number. Okay, so all I wanted to show was a POCO object being transformed to JSON or BSON. Okay, so let's go ahead and step through these two test cases. Again, I'm using MS Test, so doesn't matter, you could use any of your methodologies or NUnit or whatever. It'll be the same thing, just trying to simulate. Okay, so whenever it says generate new ID, it has created an ID for our vendor. We can send it on, and what I'm trying to show here is you need to set one more setting. So JSON writer settings dot defaults dot indent equal to true, so that the indents are correct. That's at a higher level in whichever class that you are using. You could have it this setting set up. Okay. So what the driver is trying to do is when you say vendor object.toJSON, let's go ahead and take a look at that. XML visualizer. Okay, that's a bad place. And let's look at the HTML visualizer. So this is how it looks like. So I created an object with name Charlie Sheen Acting Services. It transformed my object into a JSON. Okay, annual revenue is that much. It's US dollars. So let's go and take a look at the BSON format of the same POCO object. Again, when I'm sending it to my client, I send it using a JSON format. When I'm sending it to my MongoDB, I transform it to a BSON format. So let's look at, which is nothing but the binary format, which is a byte array. It would all be gibberish, which we don't care, but again, as long as it's transforming correctly, we're good. So that's a point I wanted to show. And the other point that I wanted to show was, how do you create a BSON document from scratch? So you can create a BSON document. Again, I'm doing the same thing, and I'm saying key value pairs. This is how I do a BSON double, because again, I don't have support for decimal. And again, I have addresses, which is a BSON array, and a subdocument embedded document, which is a contact info document that I have here. So again, what I wanted to show was that let's put a breakpoint right here, and company document.toString. I want to show the BSON document to a string, and then BSON document to the BSON format, which is a byte array that MongoDB expects. This is what I would like to show. And then I would like to deserialize back and show you the string. So to make sure it's all working properly, let's go ahead and debug through this selected test cases. Again, all I'm trying to do is create a BSON document, the right values, again each type, which is a boolean in this case, integer in this case, name in this, string in this case, double in this case, and let me show you the string representation of that. And then I would like to convert it to a bit array, which is a BSON formatted result. And this is what the driver sends to MongoDB. And to show how the driver deserializes from byte array to BSON document, let's go check, is it the same value? And obviously they are equal. which means it's doing its transformations correctly and accurately. Very good. Okay, now let's move on to the CRUD sample that we have. I still think this is super funny. I can't stop laughing. Anybody know? Don't know Mr. Bean? I wouldn't know any person who wouldn't know Mr. Bean. That's the greatest show. When I was a kid, I used to enjoy it all the time. All right, so with that being said, I would like to show you a demo of creating a student record. And okay, let's start with the MongoDB context class. So like in any ORM mapper or anything like that, or any ORM mapper, we would like to start with a DB context class. In this case, I have created a MongoDB context class, and I have stored. This is an MVC application, so I have created a MongoDB context class under app start. Let's go take a look at it. And then every call to the Mongo database starts with creation of a Mongo client. And I'm saying this is my connection string. And again, like whenever you're connecting to database, it by default it listens to the port 27017. So again, that's that. So every call begins with a Mongo client, and then you make a call to the get database, which is a demo database that I've created. And that's it. Here is your connection to the database, and get the database. So the nice thing about Mongo driver is you don't have to worry about creating a singular object where there is only one instance of the database and the connection pooling and all that. You don't have to worry about all that. It takes care of it. That's the beauty of Mongo driver, and I would like to thank them a lot for that, because it's a nightmare to keeping up with the singular, and it's not that hard, but again, yeah, any new thing, I would like to appreciate the simplicity that they provide. Okay, so with that, let's go ahead. So all I'm doing is in my, so again, one more thing. This Mongo C# driver 2.0, every operation is an asynchronous operation. So when you're writing any code that accesses MongoDB, it needs to be of type async, and it should return a task of async result, because again, all the calls to the MongoDB using C# driver will be asynchronous. Okay, so I'm getting the same database. Again, it's the same. If you go look at it, it's the same database that I instantiated, and I'm saying get my student collection of type student object. So let's go take a look at the student object. So again, I try to simulate as many data types as possible, like the frequently used string, integer, boolean, decimal, a list, or a contact information. Some people argue list is inefficient, but it's just a demo. So next thing that I would like to show is creation of a student record. It's a POCO type, right? Just like we have seen creation of a company. Now I would like to create a student object, which is my public class. Okay, and then I'm instantiating Charlie Sheen. He just doesn't go away, does he? So years in his school is 4, and is he athletic? Yes. What is his GPA? 3.0, and he lives in Texas. That's great news. And then what I'm going to do is I'm going to insert that student record using student collection that I've just retrieved here, and say insert one async record, which is a student. Okay, then I need to show you guys, did I actually save the student? So the way I would do it is create a query filter that says find all the students with contact information or phone number, being that, which is what I created in one of these things, and trying to retrieve that student list here using find. Again, you build your filter, get your student list. The next thing I would like to show is how do I update the student. let's say I would like to update the GPA of his GPA, and that is what I'm going to do. I'm going to change his GPA to 3.25, and finally read the updated student to make sure the update has happened. And then now I would like to show you how to replace a student record. Again, it's nothing here, nothing hidden. I just don't want you to go back and lose any context here. So again, then I would like to show you how to replace a student, which is replacing an entire record. I would like to find that student and replace that student with my name and 3.99 GPA. Yeah, really, my GPA was 2.1 or something like that. But for demo I could do whatever I want, right? So let's read the replace student and make sure we have replaced the student correctly, and then finally we will delete the student record. And if we try to read the deleted student, it shouldn't be there. Okay, again I would like to show you what I'm doing here. So this is again the latest C# 2.0 driver using MongoDB 3.0. So let's go ahead and debug selection and step through it. Okay, okay. So the nice thing about MongoDB, one more thing is, when you try to, if you don't have a collection already existing, it creates one for you, and I think that's cool, really cool. Just like how the entity framework read first approach we have, it provides the same approach. Entity framework, sorry, not the read first, I mean the model, the object first. Am I saying it right? There is this data model first approach and this object first approach. I think it's the object first approach. It's been so long using entity framework. Right, so with that being said, I'm creating a student record. In this case, I'm not assigning any student ID. I will let the database handle that for me, and I'm going to say insert one async. Okay, it should have inserted a student for us, and what would be a proof of that would be I have an ID, which means it's been inserted with this ID. For simplicity's sake, let's store that ID somewhere. And then we have created a filter that says find all the students with contact information dot phone number being this, and I'm going to await and apply that filter to get the student list. So let's give it a second here. So with that, we have retrieved our student list, and let's take a look at it. So let's take a look at what student did we retrieve from our Mongo database. We have two addresses, and we have Charlie Sheen 6, his number of years in school is 6, and GPA is 3, and that's his contact information. I don't know how many of you like 2.5 Men, but it's a great show. So with that being said, again, now I want to show you another update, right? So there is this update option called isUpsert. So what upsert does is, when it's set to true, if a record doesn't already exist, then it will try to insert it, and if it already exists, based on the filter options again, then it will try to update it. Okay, if a match is found. So that's what upsert means. And then we are building a query because we already know the student ID here. I'm just going to query by student ID going forward. So I'm creating a new filter, and I'm sending it that filter. So with that, I'm going to again set my GPA to 3.25. It's just I'm updating a specific field, I mean a column in a typical SQL. So again, I'm updating a field. So Let's make sure that the field is updated. Let's find the updated student list again and see what it has to offer. Yes, it indeed updated the GPA to 3.25. And then now I want to replace it with my name and increase my GPA because I can. Let me show you that. And I'm going to replace that same entire document will be replaced. Generally replaces are pretty expensive, so I would say try to keep it to updates and replace it only if you need to like rip apart the entire document and do it in that way. So let's see if the student has been replaced or not, and let's go and check. My name. Okay, so again, like not sure if it's so visible here, but again, here it is. Let me show you guys in an updated view. Okay, and then let's delete that record and be done with it. Okay, and let's try to read that. My bet is there won't be one because the student has been deleted. Using the same filter, I couldn't find the same record. Okay, so that's a typical CRUD operation using C#. So let me show you the final interface, which is uMongo. And let's refresh this. Let's say it has 0 records at this point because everything is deleted. So let's go ahead and say a insert. Okay, so what I did is I copied the document and here it is, and I'm going to say insert. It's just a typical JSON document that you would like to insert, and once I do that, I'm able to insert a record, and let's go find it. Okay, so when you're trying to find, you again build your JSON query using multiple JSON fields that you want, but in this case I know there is at least one phone number, that is this, and the fields that you would like to retrieve, do you want to sort it on ID or whatever that is. Oh, and the beauty is you can skip the number of documents initially, and how many you can limit them, you can batch them, and then you can also say which index to use for this specific query. It's a bad hint, but again, oh, by the way, I don't have a name index created, so my bet is it's going to blow up on my face, and as expected it says bad hint. So let's go ahead and create an index on name. Okay, so I want to create an index on my name, and I'm just going to say click OK. It's going to create an index, and then let's go back to the find, and right, so with that, that's the student record, and that's the address, that's the contact information that we have. And let's see what else. We show an index, create, and you can have updates obviously, and you can drop the collection if you want. Let's go ahead and drop it, and here, good. Okay, so again, there are some commands that you could use. And finally, one last thing that I would like to talk about before wrapping up this session is gridfs, where we store some files, and almost end of the session, so I just want to wake up everybody. So it's a specification for storing and retrieving files that are greater than 16 MB. Okay, and gridfs stores files in two collections. One is chunks, the other is file stores. Chunks stores the binary chunks, and files stores the files metadata. So when you use it, again, like I don't recommend storing any records in a database, any files in a database. So it's a choice, right? Again, if you want to be platform agnostic, and a little lower performance is okay, because typically it is slower than reading from a file system. So I would recommend using something else. But if you like platform agnostic performance, and your files don't change too often, then why not store it? Okay, so that's a kind of overview that I wanted to give today. And there are many other GUI links other than umongo, so don't worry if it's the one, if it's not, if umongo is not the one that you like, and there are plenty of other things. Okay, and thank you for attending this session. Hope you all have enjoyed the session as much as I did.